The ocean floor is not as boring as it looks. There are no cars down there, so it's not going to be a smooth ride. You won't even get to see the bottom because of all the water. But if you happen to be somewhere near an underwater volcano, then your trip will be far from calm. Hot magma will start bursting out of the ocean, triggering earthquakes and maybe even a tsunami. You can say that living in the deep sea is kind of like being in a horror movie. Underwater volcanoes have been the reason why we've had entire mountain ranges, island chains, and deep trenches on the ocean floor. They also cause underwater landslides, which are up to 3 times more dangerous than their land-based siblings, and shape our planet's climate. And they're everywhere. Out of about 500,000 potentially active volcanoes on Earth, over half are hiding under the oceans. Underwater volcanoes are volcanic eruptions that take place on the ocean floor. Just like their terrestrial counterparts, they form when magma from the Earth's mantle rises up through the crust. But unlike land volcanoes, most underwater volcanoes don't reach the surface. They're usually built by submarine eruptions that produce lava flows and ash that accumulate over time. If a volcano reaches the ocean surface, it becomes what we call a seamount. Seamounts can be further broken down into different types depending on how they were formed. Some of them are the result of hotspot activity, like the Hawaiian Islands. Others form along mid-ocean ridges where 2 tectonic plates are moving away from each other. As the plates pull apart, magma rises up to fill the gap, creating vast mountain chains. There are even underwater volcanoes on the tops of mountains. For example, Mount Vesuvius in Italy started its life as a seamount. It wasn't until the land rose up that the volcano became terrestrial. Well, actually, it did reach the surface at one point, but then the rising of the land caused it to become submerged again. What goes up must come down. But here's the thing, underwater volcanoes aren't always silent. In fact, they can be quite explosive. When magma rises from the depths of the ocean, it can violently erupt, sending a massive amount of ash and gases into the water column. This can cause tsunamis and even earthquakes. And that's just the direct effects. Indirect effects can be even worse. For example, underwater volcanic eruptions can cause harmful algal blooms that kill off fish and other marine life, or they can release methane and carbon dioxide, which can lead to ocean acidification. So while it might seem romantic to imagine a volcano erupting beneath the sea, the reality is much more terrifying. Luckily, though, most underwater volcanoes are fairly small and don't pose a major threat to humans. Even the largest submarine eruption in recorded history only had a limited impact on global temperatures and sea levels. However, scientists are concerned about the potential for future eruptions to cause more damage. As the climate changes, sea levels rise and the ocean becomes more acidic. These changes could make underwater volcanoes more active and more dangerous. On top of all this, most underwater volcanic eruptions go unnoticed because they happen out of sight and out of mind. Without the ability to observe these eruptions up close, it's hard to predict how they will affect the world around us. That's why it's important to study underwater volcanoes and learn as much as we can about them. With more knowledge comes better preparedness. We can use this information to develop early warning systems for tsunamis and other hazards. We can also use it to better understand the role that underwater volcanoes play in the global climate system. By studying underwater volcanoes, we're not just learning about the hidden dangers that lurk beneath the ocean. We're also gaining a better understanding of the world around us. And who knows, maybe one day, we'll even be able to harness the power of these fiery giants for good. Here's how. Volcanoes are one of the most powerful forces on Earth, capable of causing widespread destruction and devastation. But what if we could harness their power for good? Geothermal energy is a renewable energy source that uses heat from the Earth's core to generate electricity. This heat is produced by the decay of radioactive elements such as uranium, thorium, and potassium. As this heat rises towards the Earth's surface, it is harnessed by plants to generate clean, sustainable energy. Geothermal energy is a great alternative to fossil fuels as it does not produce any greenhouse gas emissions or other pollutants. This makes it an environmentally friendly option for generating electricity. Moreover, Geothermal energy is a reliable and consistent source of energy as it is available 24/7, unlike solar or wind power. One way that volcanoes can help us produce geothermal energy is through volcanic soil. Volcanic soil is rich in minerals and nutrients which make it fertile for crops. Crops absorb carbon dioxide from the atmosphere as they grow, storing it in their tissues. This process is known as carbon sequestration, and it helps to reduce the amount of carbon dioxide in the atmosphere. By using volcanic soil to grow crops, we can reduce the amount of land used for agriculture and reduce the amount of carbon dioxide emitted from farm equipment. In addition, volcanic ash can be used as a natural fertilizer, reducing the need for synthetic fertilizers, which have a high carbon footprint. Another way that volcanoes can help us produce geothermal energy is through volcanic rocks. Volcanic rocks are rich in minerals such as iron, copper, and gold. These minerals can be used to produce electrical components, reducing the demand for mining and refining activities, which are energy-intensive processes. Additionally, the heat from volcanoes can be used to heat buildings and greenhouses, reducing the need for air conditioning and heating systems, which consume a lot of energy. Overall, volcanoes can provide a sustainable and renewable source of energy. Their heat can be used for geothermal energy, their soil and rocks can be used for agriculture and industry, and their mineral deposits can be used for construction and manufacturing. By harnessing the power of volcanoes, we can reduce our reliance on fossil fuels and move towards a more sustainable future. Okay, back to the topic. Most underwater volcanoes are small and don't reach the surface of the sea. They're typically found in areas where tectonic plates are diverging, meaning they're moving away from each other. The magma that rises to fill the gap between the plates can create new seafloor and even form mountain chains. These underwater volcanoes are often found along mid-ocean ridges, which are vast mountain ranges that stretch for thousands of kilometers across the ocean floor. For example, the Mid-Atlantic Ridge is a major mid-ocean ridge that runs from the North Atlantic Ocean all the way down to the Southern Ocean. Along this ridge, there are numerous underwater volcanoes that are actively creating new seafloor. The East Pacific Rise is another major mid-ocean ridge that is home to many underwater volcanoes. These volcanoes are responsible for creating the East Pacific Barrier, a vast mountain range that runs for over 6,000 kilometers along the eastern Pacific Ocean. It's important to note that while these underwater volcanoes can create new seafloor, they can also be destructive. Volcanic eruptions can cause tsunamis and earthquakes, which can damage coastal communities. The 2018 eruption of the Krakatoa volcano in Indonesia, for example, caused a tsunami that killed over 400 people and injured thousands more. Overall, underwater volcanoes are a fascinating and powerful force of nature. While they can be destructive, they also play a vital role in shaping our planet's geology and ecosystems. Studying these volcanoes helps us understand the inner workings of our planet and the forces that shape our world.